Students, this is question number 10. You have to draw a circle. So, okay, fine. So we got the circle there. Now, what we have to do is we need to complete the figure. So we got a tangent to the circle. So there is a hit, and figure is not to scale, and this is the center O. Now we have a diameter which is RQ, and then there is a chord which is hitting the point of tangency. And we complete the figure. Okay. So this is P 54 degrees. And we have to have one more hit. So if I take this as N, there is a hit from M, and this is 20 degrees. Foremost, we are asked to get the angle MRQ. Okay, MRQ. So we are asked to get the angle present there. Now we are given that RQ is a diameter of the circle. Diameter of circle at center O. Now we need angle at R. Now I'm going to utilize a theorem that is called as the angle in a semicircle theorem. Now what does it state? The angle subtended by a diameter of a circle at any point on the circumference is a right angle. I would say is a right angle. Okay, so this is an all important theorem. So what they are trying to tell us is, now MRQ is a triangle, but RQ is a diameter. Right. So since RQ is a diameter, we are actually dealing with a semicircle. Now the angle R is inside the semicircle. So according to the theorem, the diameter is subtending an angle, and if that happens, the angle subtended by the diameter of this particular circle at any point. So the requirement is the diameter has to create this angle, and it can be at any point on the circumference. And if that happens, then this angle becomes a 90 degree. So remember, this position of the angle can be anywhere as long as it is a semicircle and created by the diameter. So sometimes it can be oriented like this, sometimes it can be oriented the other way. And this is a very important theorem, and it can occur in many competitive exams all through the educational career. So having mentioned that, this would mean you don't have to state the theorem, but you have to state the name of the theorem, stating that by angle in a semicircle theorem, like that. Now this is given for your understanding. So moving on, so this would mean angle M plus angle R plus angle Q is equal to 180. Now I don't know angle M, but I know angle R. Now angle M can also be calculated. Now since the requirement is just MRQ, so let me come back to this point. So this would mean angle R or angle MRQ is equal to 90 degree. So that is the solution. Now if in case they are asking angle M, we can also obtain that. So this is 90 degree, angle at Q is 20 degree, this is 180 degree. So this one is going to give me 110 degrees is equal to 180 plus angle at M. Now angle at M is equal to 180 minus 110, which would give me 70 degrees. So angle M is 70 degrees. This is not asked in the question, but just an additional information. Okay, so let me move on to the next part of the question. What does this ask? Now we are asked to find angle PMR. Okay, PMR. Okay, PMR is over here. Now for this also we are going to utilize a theorem. Okay, so let me state the theorem. Okay, so now let me draw your observation or your focus to the diagram. Now PM is a tangent and RM is a chord, and the angle M is created by RM when it makes the contact with PM exactly at the point of contact of tangency. So I'm going to state the theorem. Okay, this is called as alternate segment theorem. When the chord and the tangent meet at the point of contact, or the point of, when we talk about point of contact, we are talking about the point of contact made by PM with the circle. So it's a point of tangency, right? So we are mentioning it as a tangent, but we can simply state it as point of contact. So when the chord and the tangent meet at the point of contact, so contact, as I mentioned to you, it talks about the tangency with a circle. So when the chord and the tangent meet at the point of contact, the angle created is equal to the angle in the alternate segment. Now, what is the meaning of this? So we are actually interested in this angle, right? So the angle created here, which is located at M, will directly be equal to angle at Q. So this would mean angle at M, or I would say PMR. Let me state it as PMR. This means PMR is equal to angle MQR. This is the alternate segment. okay, is equal to angle MQR, which is equal to 20 degrees. So I can just state here, so therefore angle PMR is equal to 20 degrees. So that is the solution for this question. So let's move on. Now this is the next part. Now what they want here is, they want us to find PMN. They are asking us to get this angle. Now let me write that statement out. Now clearly you see here, this PM and PN are tangents. Okay, so this is a very important theorem also. Tangents, it's called tangent theorem. Tangents drawn to a circle from an external point are always equal. So this means PM is equal to PM. PM is equal to PN. This in turn means we are dealing with triangle PMN. PMN is isosceles. So what does this mean? This means angle at M is equal to angle at N. Angle at M is equal to angle at N. Let it be equal to X. So this in turn means X plus 54. This means X plus 54 is equal to 180. So 54 plus 2x is equal to 180. So 2x is equal to 180 minus 54. So you take 54 out from 180. What do you get? 10, and from 10 you get, this would give you 6, you have 7, you have 2, and then you have 1. So 2x is equal to 126. So x is equal to 126 divided by 2, 6 3 times, right? So therefore x is equal to 63 degrees. This means PMN is equal to 63 degrees. So this is a lovely question, and we have completed all the parts. Students, we need to have a figure for this. So let me draw a figure. So we have a triangle. Okay, so this is C, this is B, and we have a pole here. T, and this is A. This is 226 meters, 174 meters, and this is 65 meters. We are asked to find angle ABC. So this is required. Now I'm going to use this property. AC squared is equal to AB squared plus BC squared minus 2 times AB times BC times cos of angle B. And this can be rewritten as AC squared negative of AB squared plus BC squared. In fact, instead of writing like this, let me move this to the left and this to the right. So this will be 2 times AB times BC times cos B is equal to AB squared plus BC squared negative AC squared. I need cos B, so cos B is equal to AB squared plus BC squared negative AC squared divided by 2 times AB times BC. So I'm going to use this. I hope you got the point. So cos B is equal to AB squared 174 squared plus BC squared 65 squared minus AC squared 226 squared divided by 2 times AB is 174, BC is 65. So this is equal to, you have to use your calculator and get the value. So 174 squared 30276. So 30276 plus 65 squared 65 squared 4225 then minus 226 squared 51076 divided by 2 times of 2 multiplied with 174 multiplied with 65, right? So 22620. So this is equal to, you evaluate this, what do you get? Let me show you the evaluation. 30276 plus 4225 minus 51076. That's negative 16575 divided by 22620. What is that equal to? So divided by 22620. What do you get? You get negative 0.73278. So this is cos B. Let me utilize the space here. So this is cos B is equal to negative 0.7328. So what is B equal to? Cos inverse of negative 0.7328. Okay. So cos inverse of, right? So say cos inverse of negative 0.7328. What is that? 137.1. So this is 137.1 degrees. This is angle B. Okay, that's a solution for this question. The next part is find the area of triangle ABC. Now I'm going to utilize this formula. Area of times AB times BC, right? And then I know this angle. So AB times BC into sine of this angle. So sine of 137.1 degrees. So this is equal to half times AB is 174, BC is 65, and you take sine of this. This would approximately give you a value of 0.678. It's just an approximate value, and you multiply everything. So 174 multiplied with 65 times 0.678. What do you get? That has to be divided by 2. So area is 3834.09 square units. Everything is in meters, right? So meter squared. So that's a solution for this question. Now we got the next part. The next part says that the line TA represents a lighthouse. Okay. The angle of elevation of T from from B is 23 degrees. So we have to find the height of the lighthouse. I will show you the diagram. So this is the figure. We actually had this figure. Now this is the lighthouse. So they are giving us this angle, which is 23 degrees. 23 degrees, and clearly this is adjacent side. This is theta, and this is perpendicular. So this is going to be 90. So this is going to be my opposite side, and this is going to be my adjacent side. So I'm going to utilize tan theta. Tan theta is equal to opposite side divided by adjacent side. So this is tan 23. Opposite side is height of the lighthouse, and adjacent side is 174. So TA is equal to tan 23 multiplied with 174. So you take tan 23, and that has to be multiplied with 174. What do you get? So TA is equal to 73.886 meters. Okay, this is the height of the lighthouse. So that's the solution for this question.